And then reads, what is the limit as x approaches 0 of function 1 over x squared? Okay, so this is a reciprocal function, as we saw here, and I'm just going to graph it out real quick. Okay, so it's asking us to find the limit of a reciprocal function, so it probably looks like this. This is definitely not to scale, but f of x equals 1 over x squared, where the axes are labeled x and y. So as x approaches 0 of the function, we can see here that we can calculate the limit from both sides, okay? So we calculate the limit from one side. Oh, wait, actually, you know what? This is not right. I just realized something. It's 1 over x squared. So it should be this. Okay. Okay, so if we approach the x equals 0 from the left side, so it's 0, negative, we can see here that our function tends towards infinity. And that's the same thing with our other part of our function, right? Our right-hand side of the function. As the limit approaches 0 from the right-hand side, we also get infinity. Okay, and this is because of the nature of this function itself. So as we approach 0, right, we're getting to smaller and smaller decimal and fractions, right? So the Janine The Tutor gives us a great example here, right? So when x equals 1, right, so it's approaching from the right-hand side, we see here that the function equals 1, right? But as x equals 1 over half, due to the nature of this function itself, we're going to have the half be at the bottom. So it's going to be 1 over 4, right? Because half squared is 1 over 4. But we're going to flip that function to find its value here. So it actually equals, if x equals 1 over half, then 1 over x squared is equal to 4. Right? So as we get smaller and smaller decimals, so 1 over 100, 1 over 1,000, we get bigger and bigger numbers. And because of that, we know that as x approaches to 0, we're going to tend towards huge numbers or infinity, right? So another way that you can calculate limits is by using some test values, right? So if you're really unsure about what the behavior of the function is, then you just start plugging in points as you get closer and closer to that value of x, right? So in this case, we're getting closer to x equals 0, so we're getting smaller and smaller decimals, right? So if the Janine Tutor continued, we would have 1 over 100, 1 over 1,000, 1 over 1 million, and as we keep getting smaller and smaller, we keep getting bigger and bigger values, right? And like I said before, because of the nature of this function, as the function approaches from the left-hand side too, negative values are actually mitigated due to the squared. So that's why we have them both approaching infinity. In terms of the reciprocal function, that's why we have 1 over x. For a function 1 over x, we would have something different, right? We would have something looking like this because we don't have an x squared to get rid of the negative sign, right? So that's how you calculate the limit as x approaches 0 of a function. You can use test values, or you can also just plug it in into your limit expression. So the solution is correct. Good job. All right. So question number 8.